I'm going to dim the lights now, at this next section of algebra and studying what I like to just simplify to just abstract math. Okay, so it's just the idea of math being a little more on the abstract side. Okay, so here's what we learned last time. Last time I went over this with you guys, and it was just last week. The basic thing you learned last time was that in algebra, multiplication is done by putting either two things directly beside one another, like 2x means 2 times x, or using brackets. 2 in brackets beside 5 in brackets means 2 times 5. Okay? The method I taught you guys last time was working with formulas. If you know the value of a variable, then I gave you these 3 steps to solve the formula. Okay? To figure it out now that you know what the variable is. Okay, so algebra is just a fancy word in math that just means solving puzzles, solving problems. And you have to solve puzzles by, there's something you don't know, and you're trying to figure it out, right? You're trying to figure out how much to tip a waiter. You're trying to figure out how much lumber you need to buy to build a fence. Algebra affects you in the real world, but in math, we write it with a combination of letters and numbers, okay? Now, in order to do this, we're eventually going to have to use our arithmetic skills. This is the stuff we learned in the last unit, stuff like adding and subtracting and multiplying. And it can get more fancy than that, like things like fractions and decimals. But that's arithmetic. Arithmetic manipulates the numbers. But let's look at it this way. Say you had a puzzle and a piece was missing. Then you can't solve it. There's no way to solve the puzzle if the piece is missing. But then all of a sudden if I find it, oh, it was under the chair, it was under the couch. Once you find the piece, the puzzle gets completed, right? You've solved the puzzle once you have the missing piece. That's what algebra is. It's about solving that puzzle. It works the same with the letters and the numbers. So if I go, okay, it's unknown, something plus 5. Right here, you can't solve it. It's like the missing piece, we can't possibly solve it. But then what if I tell you, oh, no, what the x is it's a 2. Oh, now that I have the missing piece, now I can put it into the puzzle, 2 plus 5, and get 7. So once I have the missing piece, it's solved. But obviously this gets more complicated. What happens if I never know what the piece is? Can I actually reverse this process and try and solve it? What if I don't know what I'm looking for? Can I still work with the algebra? Well, the answer is yes. But let's pull it back to the puzzle example. If you don't know what this puzzle piece is, if you're smart enough, you can imagine what it looks like. You can imagine the piece that would go right there. So here, look at this little animation. I can imagine what the piece would look like right there. And then I can kind of at least visualize what the solution to this puzzle would be. I mean, some of you have probably seen that when you did puzzles as a kid. It's like, even as you started to put the puzzle together, you kind of knew what it was going to be before you put all the pieces in place. Well, we can do that in algebra too. We can go, okay, here's a piece of the puzzle. Something's missing from that puzzle, but I can imagine what it could be. I can kind of guess what would that piece be that's missing from that puzzle. So I can, just the same as I did with the actual puzzle, I can go, what if x is 2? Now, in my guess, I could then check that. I could go, oh, well, what if I just put the 2 in there? Oh, look, it does actually check out. That was the missing piece. This process is called guess and check. You've probably heard of it before. It's useful in some instances. But right away, the algebra will start getting too hard to do it this way. So what if the algebra gets as complicated as you see here? 6x, 2 plus 3 minus 4 over 5 equals 256. If you were to try and guess what x was, you'd be guessing for a long time, trying to figure out what x was, just guessing. So that's not going to work. So although guess and check can work in some instances, like back when it's simple like this, obviously we need a better method. We need a better method when the math gets harder, when the algebra gets harder. So we need a new method. We need a new way to do this. Okay? So I'm going to teach you a way. But before I do, let's once again examine these words. Here's a word you're going to hear in math class. Equation. You're going to hear that word. You're going to hear it. You're going to see it on tests. You're going to see it not only in grade 9, but in 10, 11, 12. It's not going away. That word is actually, again, comes from Latin. Most of English comes from Latin. Latin is the base language of English. And the word was equatalus, I think. I'm not sure exactly how to say it. But in Latin, it just meant to make things equal or to make things level when they were building things. They said, oh, let's just make it level. You guys know what level means? How many of you are taking woods? What does something level mean? Is this table level, for example? Yes. Yeah. Is the floor level? Yeah. It just means it's, balanced, right? If you put a ball on it, it's not going to roll off one side because it's level. Another way you could think of that word is it just meant to make identical, right? To make two things the same. That's where the word came from. We even know this a little bit. The word equation in English is like the word equal. Equal, equation, they're kind of the same word. So to make two things equal, okay? In algebra, it's an equation if it has an equal sign. That's it. That's the way you want to think of it. If it has an equal sign, it's an equation. So x plus 5 is not an equation. There's no equal sign there. In math, we call that an expression. Don't worry about that. That's not a big deal. But know that that's not an equation. But if I say x plus 5 equals 7, it's now got an equal sign. So now it's an equation because it has an equal sign. So basically, anything with an equal sign is an equation. Pretty simple. Now, once it's in the form of an equation, it's a puzzle. Now it's a puzzle that we can solve. When it was this, just x plus 5, we couldn't solve it. There was no way to solve it. But when it's in the form of an equation, we can solve for it. Okay? Now, we could use guess and check. In this case, it would work. But again, we're going to work on a more complicated method in a minute. Okay. Now, when you think of math, you could also start thinking about the language of writing. Okay? In writing, they actually use some of these words as well. So, for example, when you're writing an English class and you're writing a sentence, your English teachers will say it must be a fully formed sentence or a complete sentence, sometimes they use the word, not just an expression. So, for example, if you write this as a sentence, your assignment, your English teachers will get on your case. They'll say, nope, that's not a complete sentence. But if you say your assignment is now due for marking, that's now a fully formed sentence. Same in math. X plus 5 is not fully formed. X plus 5 equals 7 is now fully formed into an equation. And now you can solve it. That's why the word form is the basis of the word formula. Okay? Some fancy words there again. All right. Here's the graphic I made to summarize everything we've learned so far in terms of the words. The word arithmetic is Latin for arithmetica, or arithmetica, which is the art of working with numbers. It's very poetic. And arithmetic involves numbers, which are just symbols we use to represent things, and functions, like operations we do on numbers. We perform operations. This is like a medical drama. You're performing an operation, just like a doctor performs a tracheotomy on somebody. That's what arithmetic is. But now, after you're done learning all the arithmetic you can, which you should have done now, we go on to algebra, which algebra is using math and using arithmetic to solve puzzles. And the way that works is we have to have something that we don't know, an unknown. We call that in arithmetic, or pardon me, in algebra, a variable. The variable is the unknown. We write it with a letter in math to symbolize the thing we don't know. We have equations, like I just told you about, which is algebra written with an equal sign. If it's written with an equal sign, it's an equation. And we have formulas, which is an equation that forms a solution by using the unknown, which is the variable, and replacing with a value to solve it. So these are words. Numbers, functions, variables, equations, formulas, algebra, and arithmetic are just words we use in math class to describe what's going on. If those words were confusing to you, Don't overthink them. They are fairly simple in what they're actually describing. Okay, so let's think of a simple concept. Balance, okay? Can any of you guys balance on 2 of your chair legs right now? Any of you have that ability to do that? Can any of you do that? Can you actually balance on 2 legs? Used to be able to pull that off, but it's not too bad. You're good maybe at balancing, okay? I can tell you in 16 years of teaching, I've seen students lose their balance on chairs more than one time. How many of you have had the experience where in class all of a sudden loses their balance, they were leaning back on a chair? And has anyone ever seen someone get seriously hurt that way? I have. I've seen people like bleeding that they've hit their head. I don't want, but most often when it happens, students just laugh, right? Someone falls in their chair, it's a funny event. But it's all about balance. Okay. Now that you know some of the language of math, okay, we need something better than guess and check. We should understand that equations are all about balance. Balance means one side equals another side. That's what balance means. One side must balance the other. Think of it like a teeter-totter. Look at this fun little graphic. You guys haven't used those in years. Maybe some of you have used them recently. But a teeter-totter or a seesaw, if you have 4 big fat kids on one side of the seesaw, for it to balance, you got to have 4 big fat kids on the other side. Fat with a PH. Like they're cool, fat.
Yeah, but you hear that. There's no difference.
I was just joking. All right. Hey, I'm a fat kid. Well, I'm not a kid. All right. So here, let's look at it this way. Forget the kids. If I put 3 boxes on one side of a teeter-totter, in order for it to balance, I got to put 3 boxes on the other side. If I put 4 boxes on the other side, it's not in balance anymore. If I only put 2 boxes on the other side, it's not in balance. This is so simple. Very simple to think about balance that way. But that's what math is. In algebra, if you say 3 equals 3, what you're essentially saying is the equal sign is the center of the teeter-totter. And what's on one side balances what's on the other side. If I say 4 equals 3, that doesn't make sense. That's not balanced. Pretty simple. Okay, so let's take that concept and work with it. Now let's say we have something that we don't know. We've got these 3 boxes on this side. We've got 1 box over on this side, and then some box that we don't know what's inside of it. We have no idea what's inside this box. But we know right now the teeter-totter is in balance. So what if I decided to take 1 box off this side? I'm just going to take one away. Sorry, this side. It won't balance anymore unless I do something. Let me go back. The box is here. Visualize this in your mind. If I take a box off this side, in order for it to balance, because right now it's starting to teeter this way, what would I need to do to this side? Take a box away, that's right. And then it goes back into balance. Right? Think of it again. If I take one off this side, I have to take one off that side for it to be balanced. It's a simple concept. Okay? You guys probably had that experience as kids when like 4 or 5 of you were on a teeter-totter and then 4 or 5 other kids were on the other side. And did everyone ever do that trick where like 3 guys jump off one side and the whole teeter-totter goes flying? I did when I was a kid. Kids got hurt that way, but that's the way it worked. But in order to balance it, you got to always keep things one. You do what you do to one side, you got to do to the other. Okay. And that's the key. What we do to one side, we have to do to the other to keep it in balance. Okay? If we add things to one side, like let's say I added a box to this side, then I have to add a box to this side to be in balance. If I remove items from one side, I have to remove them from the other side. The key phrase here is what it says right there. What you do to one side, you have to do to the other. I would actually recommend you repeat that out loud with me right now. What we do to one side, we have to do to the other. Okay, don't do it. Okay? It helps you to remember that. This applies to algebra. So let's see. Here's some algebra. X plus 1 equals 3. Now we could use guess and check, but let's use the concept of balance here. That's the balance point right there. What I do to one side, I do to the other. So, why don't I take one away from this side? And to keep balance, I'll take one away from this side. Well, 1 minus 1 is 0. 3 minus 1 is 2. So this is true, and we're still in balance. And we've solved it. X is 2 here. We could have used the guess and check. 2 plus 1 is 3, and 3 equals 3. Yeah, that works as well. So the whole concept here, and this is a simple example, is what we do to one side, we do to the other to keep balance. Okay, so now we can start working with this. With this concept of balance, we are solving the puzzle. We learned what the variable was by solving using balance. The formal way that this is often said by math teachers is solving equations. That's why I figured out, I wanted to show you what the word equations mean. Okay? We basically added or subtracted from both sides until only the variable was left by itself. This is called isolating the variable. You're going to hear that from math teachers as well. Isolating is not that fancy of a word. It just means to make alone. Like when you're isolated on a desert island like this, you are alone, right? Like anyone see Castaway? Great movie. You are by yourself. You have isolated yourself. That's what it said when you are removing everything except the variable. Okay, so here's the method. This is the step-by-step. 1, do any arithmetic you can first. So before you get started with any of this algebra, if you have arithmetic that you can do, if you can do some adding and subtracting, go ahead and get that out of the way first. Remember though, you can't do arithmetic with a variable. So if there's a variable there, then you got no more work to do. 2, now keep balance by adding or subtracting from the part of the puzzle where the variable is. And again, you're going to see this in an example. And you do that by always doing the opposite. The opposite of what's there. And you'll see that in the example. And then when it's alone, you're done. That's when you have it solved. So let's try it with an example. So here's the algebra. We're not going to use guess and check. I know some of you can probably guess that right now. We're going to go through the steps. 1, is there any arithmetic we can do? No. I can't do arithmetic with 10 because it's by itself. I can't do arithmetic with this because I don't know what x is. No, but I can't. There's nothing I can do arithmetic here, and there's nothing I can do with arithmetic here. Okay, so I move to step 2. What I can do is I can take 7 away from this side, but what I do to one side, I do to the other. So if I take 7 away here, I have to take 7 away here to keep balance. Okay? Now, why did I take away 7? Because I always do the opposite of what's already there. So the opposite of plus 7 is minus 7. But what I do to one side, I have to do to the other. Again, this equal sign is like a divider. One side over here, one side over here. What I do to one side, I have to do to the other. And now I'm done. Because now, 7 minus 7 is 0, which means it goes away. And 10 minus 7 is 3. And I'm done. X equals 3. X is now alone. It's isolated. It's all by itself, which means I'm done. I'm solved it. And if you did guess and check, you probably realize that that is, in fact, the right answer. Okay, let's try another one. Simple ones to start. The name for this, formally, is called the inverse operations method. That's the name of this method. Yes? Nope. We had that discussion. You can hold it. We're almost done. Okay? So now, we have to keep doing the opposite, or the inverse. So here's an example. Here we have a variable. Can't do any math on this side, or any arithmetic. Can't do any arithmetic on this side. What I can do is the inverse, or the opposite. So the opposite of minus 25 is adding 25. And I do it to one side, I do it to the other side. So when I add 25 to this side, it just goes away. It becomes 0. But when I take 54 and add 25, I get 79, and I'm done. Because now x is by itself, and I'm done. Okay? 3 steps here. Now, in both of these 2 examples, we didn't have to do anything for step 1. There was no arithmetic to do. But now I'm going to change that. Let's take a look at this example. So in this example, it's a little more complicated. X minus 8 divided by 2 equals 5 plus 6. So now I go to step 1. Here I can do some arithmetic first. I can do 8 divided by 2. I can do 5 plus 6. I can do that first and get it out of the way. I get x minus 4 equals 11. Now I can do the inverse. So now I go, oh, okay. This is a negative 4, so I'll add 4. But what I do to one side, I do to the other. So if I add 4 here, I add 4 here. Those two go away. 11 plus 4 gives me 15, and I'm done. Now the variable's all by itself, it's isolated, and it's solved. So here you can see, although it rarely needs to be done, you might have to do a little bit of math first to make your life easier. Because if you didn't do step 1, you might have got confused by that question. It might have caused a problem there. All right. So now we have a method. How do we check it? Well, you can hand it in, and I'll tell you if it's right or not. But you may remember back in the beginning of this unit, I said there's 5 steps to solving a problem. Define it, find a method, analyze the method, find the solution, check the solution. And I said these 5 problem-solving steps will work on anything. Okay? But now when we look at it in algebra, step 1 is figuring out what the question's asking, knowing the vocabulary, knowing the words being used, like equation, isolate, inverse. I'm going to be using those words in the assignment I'm going to give you guys. It's going to say, solve the equation, and you should know what that means. Then find a method. Well, I just gave you a method. Okay? We just have one. Step 3, analyze, which means you actually use the method. So you go through the steps of the method and figure it out. Work the algebra. Work the arithmetic. If it's hard numbers, use a calculator. That's what calculators are for. Calculators are arithmetic machines. Come up with an answer, but how do I check it? Well, now I'm going to tell you the way. A good way to check your work is to go back to what we did in part 2, which is now that you have a solution, put it back into the formula and see if it works out. So here, let's try this. So step 1, I was going to solve this. So I would have went through the steps, any arithmetic, no. Subtract 7 from both sides, and I get x equals 3. So now I've solved it. How do I check it? To check if I got it right, I rewrite the math problem. X plus 7 equals 10. That's the original math problem. I substitute in my answer. If it involves multiplication, which it doesn't, that's going to come up in the next part. And I solve it, and I get right here a balance. 10 equals 10. If I get that, that checks out. X is 3. It checked out. So you can check your own work by doing what we learned in part 2 of this unit. Okay, let's try it again real quick. Let's solve this. We solve it again by any arithmetic needed. Nope, no arithmetic. Add or subtract, so I'm going to add 25 to both sides. I now have it solved. X equals 79. I have a solution. Does it check? Well, let's check it. I rewrite the original x minus 25 equals 54. That's the original. I rewrite it again, but instead of writing x, I put the 79 where the x goes. 79 minus 25 equals 54. I calculate that out using arithmetic, and 54 equals 54. It balances. That's what you want. Simple, step-by-step doing these problems. Here's the summary for today. There are 3 words you need to know at this point. Equation, inverse, and isolate. Those are words you need to know. If you don't understand them, please study those so that you understand what the questions are asking. If they say the word equation, inverse, or isolate. The method is the 3, and I'm going to add the 4th step, which is to check it. These 4 steps for solving equations. Now, the equations are going to get harder. Right now, they're at a simple level. But I'm going to increase the difficulty to the level where you need to be to get to the grade 9. But right now, we have a pretty good method for solving some of these ones like that. Okay? Real quick, let's just do one on the smartboard before I wrap up today. Okay? I'll just do one right now. X, that's my unknown, minus 4 equals 20. Okay? Step 1. If I have any, actually let's make it a little bit harder. 20 plus 2. Step 1. If I can do any arithmetic, do the arithmetic first. Remember, the equal sign acts as a spot that balances one side versus the other, like a teeter-totter. So I look at each side. Can I do any arithmetic with that? No. That's a variable. I can't do anything with that. But on this side, I can do something. I can do 20 plus 2. So I'll do it. And I get 22. Now keep writing the rest. So the rest of it was the same. Okay, so I'm there. Now it's still a teeter-totter, balancing right there. Okay, so the goal is I just want x alone, or the word we used was I want it isolated. I want to isolate x. I want it all by itself. So it's not by itself. There's a minus 4 right there. Well, I can get rid of the minus 4 with the inverse, which means the opposite. Okay? So isolate just means by itself. I want x by itself. Inverse just means to do the opposite. Okay, so let's do that. That's a minus 4. I will add 4. That'll get rid of it. But to keep balance, what I do to one side, I do to the other side. So if I'm going to add 4 to this side, I better add 4 to this side. And now I rewrite it. X, because the 4 is gone, equals, well, 22 plus 4 is 26. And I have balance still. And I've solved it. But now, I got to check it. So here you can see, and I don't expect you guys to be drawing teeter-totters on your work. That's a waste of your time. Okay? You're going to be just doing this a lot quicker without the teeter-totters. Whoops. How did I lose you, little plus 2? Oh well, let me just shrink this down. Bring that little guy over there. So now I'm going to check this. To check this thing, to see if I got the right answer or not, I'm going to rewrite the original. X minus 4 equals 20 plus 2. That's the original thing. Then I'm going to rewrite it again, right underneath it. But instead of writing x, I'm going to write my answer. 26 minus 4 equals 20 plus 2. And now I just do arithmetic. Well, 26 minus 4 is 22. 20 plus 2 is 22. I have balance. This checks that that was the correct answer. That's how you do it. Okay? It's a simple process if you understand the method. Okay, let me just stop that.